Hello, my friends of Qatari Labs. My name is Montoya. Welcome to this tutorial. In this tutorial, what we are going to do is the development of a groundwater model in the area of influence of a mine project. Okay, here we have a mine project where we have the pit, we have the tailings dam and the waste dam, and we are going to create a regional groundwater model that will be the basis for that will be the master model for that will be the basis for some child models, that is the seepage flow from the tailings dam, that is the seepage flow from the waste dam, and also the pit inflows. Okay, so we are going to start. Okay, in the description of this video you are going to receive one link. In the link you have to insert the password, that is Qatari Labs with capital H. Great, we download the zipped file that is on RAR, so please use WinRAR to unzip it. Okay, and this Control C, you have to place it here on your document folder and extract. Great. Okay, so let's open Anaconda Pro. Okay, here is CD documents, CD dear, CD create regional model with MODFLOW6. Here we launch Jupyter Lab. Great. What is the first step is to update mf6Voronoi, and this is a good practice. What is a good practice? To update mf6Voronoi, because this is a changing, a developing library. So every time that you want to do something, please make sure that you are on the latest version of the library. Okay, so here okay, so let's go to script, and then we are going to do a new notebook, and this will be part 0, because part 0 is a part for the code generation. Why we use some notebook generation? Because with mf6Voronoi we have templates, and those templates actually are the templates are really helpful, and are the only way to download or to work efficiently with mf6Voronoi. Otherwise you will be required to be you will be required to be typing every command, every step, and this is too lengthy. So with the template you work around twice as fast. Okay, your speed will be double on the creation of MODFLOW model, or at least double. mf6Voronoi utils import list templates and copy template. Great. Okay, so we are going to list the templates. Okay, we have the first one for the model creation, no, for the Voronoi creation, and for the model creation we're going to use this number 1, number 2, and the BTK generation as well. Okay, so here copy template of generate Voronoi mine. Okay, copy template model creation mine. Okay, mine is the prefix for the files that will be created, and the other is copy template BTK generation. Great. So here we have the P1, P2, and P4. So let's start with the P1. Okay. So we are going to import the required packages. The model will be called mine regional. The maximum reference will be 800, and we are going to use overlapping faults. Okay, just to, this is for the point cloud generation, so one object won't define so many points for the refinement when it's overlapped by the other points. So that is why overlapping faults. Okay, so you will get a cleaner mesh with overlapping faults. Okay, the basing will be from Hatari utils, that is Hatari utils catchment.shapefile. Then we are going to tailings shapefile tailings envelope. Okay, so tailings envelope.shapefile, and in this case we are going to use 100. The second one will be the pit, and this is the picture, and this will be as well with 100, and this is the dump. Waste down. The river. The river will be of Qatari utils dot river. I will open a QAS to show you the file. Okay. The river. This will be of the river basin dot shapefile, and the river basin will have a discretization 150. And then you have the buffer. Okay, and then you have a buffer that is, this is new in this exercise, that is a buffer for the to the inside that allows us to have a refinement on the boundaries, and why we need this. Okay, so let's go to home, to documents, to, okay, so here we have the catchment, here we have the river basin that actually you cannot see very well, and then you have the pit shell, waste dam, and tailings envelope. Okay, so what is the buffer? Okay, the buffer is an object that is a parallel, is a line that is parallel 500 meters inside, okay, that allows you to create a utilitarian refinement on the border. But this utilitarian refinement allows you to have, because if you see, this border is actually not is not regular. Okay, so it's that come from a pixelation, so actually it's pixel. So sometimes you don't get all the cells, but when you create a refinement, okay, when you get a refinement, you will when you get refinement, all of these geometries will be included on the final mesh. Okay, so that's why here we use the refinement. That's it. Okay, so it's doing its stuff. Great. We have 10,000 elements for a regional model that has a refinement over the mine facilities. Okay. So then we have the output. Okay. Okay, this is one level up for the output to store the shapefile. And then we can read that shapefile, upload it. And that is the beauty of the Voronoi mesh. Here we have the utilitarian refinement, the refinement along the drainage network, and then we have the refinement over the tailings dam, the waste dam, and the pit. Okay. However, my recommendation and the coming webinar is local women where we are going to do child model from this and it's really easy to do child model from this regional model. It's really easy. Okay, so that is why we don't get with much more with smaller discretization here around the pit or whether here around the waste dam, because we are going to do child models. Okay, and on those child models, we are going to end up with discretization of the meters, for example. Okay, great. And now we are going to create the JSON, the dictionary with the grid. Okay, so we got this. So we get the cell2D data, and then we create a JSON folder. So a JSON folder will be created at this level, and here you will have the DSVD. Okay, there was a JSON file, but now you have it. Great. Then we are going to create the model. Okay, so now on the script. Okay, so we have already the grid already on the JSON and stored here as a JSON .json. And now what we are going to do, we go here on mine. Okay, and then we are going to work with the modeling itself. So, okay, there are some warnings here, but this is due to incompatibility, so whatever, this depends on the Anaconda version, Python version, so it's really a, how we say in Castilian and Spanish, telenovela. Okay, so then we open the JSON, great, and then we open the raster file, so will be rst, and the name of the raster file is clip them 100 meters. Okay. About the minimum will be 100 minus 20, 85, 50, 70, and 50, and 5 layers. Okay, still working with 5 layers. Okay, so we are going to work in the model name is mf6 model, and the folder will be mf model files, okay, but one level up because we are working under the script directory, and the executable will be one level up being mf6.x. If you work in Linux, okay, you have to download your own. Okay, great. One stress period times seconds. Okay, I think that the latest version of mf6Voronoi will come with seconds already as the default. Okay, Newton under relaxation. Complex. We import the DSV. And we import the initial condition that all the model is saturated by default. Okay, there is a shapefile that is cross-section. That is a shapefile that we use to show you the geometry on cross-section. Okay, this is really handy. You can see it. Okay, this is really handy, and if you want to look for another cross-section, just change the direction of this shapefile, and then you will have your whatever cross-section that is on your interest. Okay, so we are going to leave the first two layers are convertible, while the latest one are confined, and these are the k values. And then if you want, okay, here I will insert a new. Okay, well, you have to, this is a, okay, you go to the cross section and then you plot the k array. Okay, you plot the k array here, and these are the values of k that you have implemented on the logarithmic scale. Okay, this has, you have to type it. Okay. On the storage, we are working on steady state, so nothing to say here. The recharge and the evapotranspiration will be 150 millimeters per year. The recharge and the potential evapotranspiration is 1,200 millimeters per year. Okay, great. So we have we define the inter-X, okay, the river network utils. So we get the river basin. We apply that with a conductance of 0.01, and then we can plot the river network. Okay, so this is the river network. This is the... Okay. I say something that you have to. What I have told you is that you have to update mf6Voronoi. Okay, so I am working with Anaconda from. So, and then you have to do it at the beginning. Okay, I think that for this tutorial nothing will go on, but okay, so if you want, okay, you can do it in any time. Pip install score capital U mf6 Voronoi. Okay, it's always a good practice. Okay, and then here in the version 0.023. Okay, I'm not going, because the next step will be to restart and run again, but it will take time, and I think that, well, okay, well, let's see, restart again and run to the Okay, we restart again, and okay, in order to see the latest, the change, okay, or in order to work with the latest version. Okay, and then we run the simulation. And the simulation is here in model files. Just wait a bit. My recommendation is that you follow the steps here, and then uh, try to adapt this uh, to your own data, to your own case. Okay, but whatever you want to do it with mf6Voronoi, please follow the tutorial from the beginning to the end, because you are going to get the idea of the you are going to get the idea of the software. Okay, and then later on you can practice with your own. Okay. I don't know what is going on here. Don't know. Okay, I will stop. Something went wrong. Okay, I will reload the okay, I will restart and run on 7. No, restart and run to this one, to the selected cell. Okay. Great, 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 great. Okay, we got stuck. That's finished. Okay, so we can import the heads. Okay, there is only one stress period, and then we can plot the figure. Because the model creation, that this template works on a steady state. The multi-layer transient works with transient models. And I'm really happy because I don't have like 20 templates. Okay, I have 3 templates, and mostly of what I do, I can do it with these just 3 templates. I don't know, something went wrong. It is stuck again. Okay, okay, okay. It was taking time. Right, so this is the distribution of the heads for the, well, this is with the Newton Raphson, this is for the layer 4. Okay, that's all right. But now, okay, this is just a preview. But here you have the VTK generation, that is where the magic happens. Okay, so we open model file, and the folder will be VTK. So we open the VTK. Hey, follow us. Okay, you have all our social network. We have one model. We get the head, we get the geometry arrays. The parametric. Okay. The head and the water table. So then you go here to Paraview. Okay. There is another here. There is another script. Okay, that this script actually creates from the shape files, creates some BTKs for the geometry or the for the tailings dam, the waste dam, and uh, and the pit. Okay, so I'm not going to, well, this was on a, okay, so it creates these geometries, these BTKs, and I'm just going to kernel, restart, and run all cells. Okay, great. So this will be okay, this will be on BTK folder. So on the BTK folder, besides of having the model, we have also the BTK for the dam, waste dam, and the pit as well. Okay, so let's open the Marveling Paraview. Mhm. And we can open from documents, from create, from BTK, we are going to open first the pit, the dam, and the tailings. Okay, these three. So this is the pit, and here is the dam and the tailings. Okay, let's open the drainage network as a solid color. Great. Okay, now let's open the key values, for example, model parameters, key values. But let's do a clip because we want a key values in this cross section. Okay. Invert that. No, no, not. We can, no, actually no. Okay, so okay, so we are going to use the k value. We enable the log scale, and then we select the other, for example, this one. Okay, and as well some opacity. A surface with edges, and the edge will be another color. Okay, great. For example, now what we are going to do is we are going to import the water table, and this is the water table. Beautiful, amazing. I mean, look at this level. Please look at this level. Oh, I take out the. Okay, please look at this level of graphics just with open source software. Okay, because you are not paying for it. Okay, not why we use open source software, because it's a tool that can be widely available for all all actors, all stakeholders, all people interested. Okay, so there is no limitation on the use of that. You are free by using open source software. Okay, so freedom is what it rules our world. Freedom on the, and then we hope that freedom on the software will also mean freedom on the mind. Little science. Great. So, and then we open again the water heads, apply. So since we are using the Newton. So we go here to so we are going to do a threshold. Okay, and then here filters will be cell point to point data. Then here will ISO volume. So it's threshold, cell data to point data, ISO volume, and then contours. The contours has to be the contour has to be on the same CMap, color map, inverted. Okay, and the water table will have some opacity, decrease opacity, and then that is okay. Take out the layer. Okay, and this is the groundwater modeling of a waste dam. Okay, no, of a regional groundwater model. Okay, with a regional groundwater model with a complete mining project. Considering a complete mining project, and as well here there is a final trick. Well, there are many tricks, okay, but okay, the line width will be 5 here, 5 here, 5, as well here on the tailings that will be 5. Okay, and I don't like, well, the tailings, the color, the solid color. Let's see that the tailings is this one. And for the pit, let's use another one. Okay, amazing. Great, so that was the tutorial. All the files are on the description of the video. Thank you for following us. Just well, there will be more tutorials, for example, how to do a child model, but it will be based on this one, okay, and as well the transform models as well. Have a nice day.